So often in maths, the bridge, the path to know something, learn something that you don't understand yet, is to compare it to something that you do know, that you do understand. So that's why I'm beginning here, because this is something that we can all do. 5 times 12, what's 5 times 12 equal to?
60.
60. 60?
Yeah, 60.
60. 60.
60.
0. Okay. Perfect. That's exactly right. Okay. And there's a few different ways that you can see that. For example, you could have said, 12 is 3 times 4. Right? So if 5 times 12 is a bit too big for you, you can do 5 times 3. And then that's 15. And then you multiply that by 4, you'll get 60. Same deal.
Or you could just half 12 times by 10.
Yep, you could say 5 is actually 10 divided by 2. So you could do 12 times 10, 120, and then do the division, which would give you 60.
Or you could do what I said and divide 12 by 2 and then just times that by 10.
Yeah, that's what I did.
It's same thing. Same thing.
No, it's slightly
It's slightly
I've
different.
memorized.
Okay, no, well, same thing in that you'll get the same result.
I've memorized the 12 times.
Okay, or you could have your times tables memorized. Now, I want to show you one other way of doing it, which because we have all these other strategies for doing it, which work just fine, you probably don't think about, but will be very instructive for this, okay? 5 times 12. I'm going to rewrite it in a little different way, okay? I'm going to write this as 5 times. Now I'm going to choose to break up the 12, rather than say 3 times 4, right? I'm going to break it up into 10 plus 2. Okay, this is still the same thing, right? 10 plus 2 is still 12, and I'll put the brackets around to indicate that whole thing is being multiplied by 5. All of it. That's why it's 12. Okay. Now, if you remember back to last year, we learnt, we talk about laws and stuff like that, right? Shortcuts, laws, shortcuts. We learned a particular shortcut for this called the distributive law. And this big important name, the distributive law. In case you can't, distributive law. Bit funny to spell. And what it means is when you say 5 times these things, the 10 and the 2, that 5 times it distributes across all the numbers inside the brackets, right? That's why it's the distributive law. So there will be the 5 times the 10, and there will be the 5 times the 2, right? Everyone inside the brackets gets a 5 times. It gets handed out to everyone.
Okay? You get 5 times.
So yeah, exactly.
No.
How would that look on the next line? Okay. Well, 5 times 10, of course, is
5 times 10 is
50. And 5 times 2 is 10, which is, as you expected, it's still 60. It's still the same thing. It's just another way of looking at it. Okay? But we're going to use this idea that whatever's at the front will get distributed to everything inside the brackets when we look at algebraic expressions. Because even though we're doing the same thing here, it looks rather different. So sometimes your brain can kind of weird out and not know what to do. Let's have a go. Excuse me. I'm going to use this same principle of distribution. Okay? Again, I've got a 5 out here, right? I'm going to distribute the 5 to everything that's inside the brackets. First, there's an M, and then there will be a 3. Okay? So, 5 times M, with my algebraic, abbreviations, I would just write 5M. 5M. So there's the first distribution. With the second one, I'll go 5 by 3, which gives me
15.
Perfect. And that's it. I've expanded it. Can you see? I don't have any brackets anymore. They've left behind. I've got the whole expression, and it's been evaluated. Okay? So it's fine. This is not complicated. It's exactly the same thing we're doing here, but with algebra in the mix. Okay? Let's give this one a go. Right? This time we've got an 8 out the front, and again, it's distributing. But you just have to be a little cautious because, for starters, there's an M there, no big deal. 8 times M will give me 8M. Perfect. Okay. But this 8 doesn't just distribute to a 2, it distributes to a -2, right? So the sign comes along for the ride. Just like this plus becomes a plus here, this minus will also become a minus over here. So this should be minus 8 by 2? 16. 16. Okay. So I have taken this, which has brackets, I've gotten rid of the brackets, and I have expanded. That's what this process is called. This is called expanding. Okay? So this is simple. Let's just do 2 final examples, and then I'll let you have a bit of practice, right? Here, what I've got out the front, this guy's got a minus sign, right? Do you remember how we said the minus sign comes along for the ride, right? Well, this time, the minus sign comes along for the ride twice. Can you see why it happens twice? The minus 3 gets distributed once, and then it gets distributed twice. So they're both going to get the minus 3 applied to them. Minus 3 times n should give us minus 3n. Well done. But then minus 3, again, times 4 will give me minus 12, right? That's 3 times 4. Can you see what's happened? Now I've got minus signs twice because I've distributed twice, okay? I suppose if I put another term in there, like 3 terms, I'd get 3 minus signs, however many times. Last one. Now I can do this first term fairly easily. I'm going to stop drawing the arrows because I think you can see what's going on, right? I'm going to go minus 4 times v minus 4v. But what happens to the second term? This is a bit sneaky, isn't it? Rachel? Yeah, fantastic. I've got a minus 4 times minus 5. And when you've got 2 minus signs, they cancel each other out. You'll just end up with a positive. And of course the sign is 20. Okay? Does that make sense? So can you see here, 1 minus sign out the front, and it's become 2 here because it gets distributed twice. This guy got distributed twice too. It's just that he collided with this guy, and they cancelled each other out. Make sense?
Yeah.
Awesome.